it would not be a two-stage vehicle, it would be a single-stage vehicle, directly being able to get to orbit because it's much lighter and much stronger. And so that could be a great advantage for us and could actually, and that I think is what's required for space to be accessible to everyone. Think of a luxury spaceship that's taking up its crew, go up there, hang around in space for a few days, and then just come back down to Earth whenever it wants to. That's the vision I see, and that's feasible only if you have a single stage vehicle.
This is Gadhadar Reddy. He is an inventor, entrepreneur, and a visionary who's working on the long term goal of enabling humanity to be a spacefaring species. As a founder at NoPo Nanotechnologies, which brilliantly stands for Not Possible, and with his eyes set on Mars and space travel, he is working on scaling the production of carbon nanotubes, which have shown to have several advantages in electronics, thermal protection systems, structural composite, and many other applications. I love the fact that he is working on the fundamentals of material nanostructure and its synthesis, and he's an inspiration to me. In this episode, we talk about nanotechnology, space travel, and entrepreneurship. Here is my conversation with Gadadhar Reddy. It's often difficult to relate to objects at lower scales than 10 power minus 3 meter or millimeter scale, but there is both a living and non living world at much smaller scales, which gets little attention but an essential building block of the universe. So, to help the listeners relate to what we will discuss in this episode, let us start with some applications of nanotechnology. More specifically, can you talk about applications of nanotechnology that one might encounter in their everyday life?
Yeah, sure. So nanotech is actually present everywhere. See, it's mostly about understanding how things are working at the atomic scale. So this new understanding is really what gets the field its name. So silver has been used for a very long time in its nanoparticle form for protecting us against any kind of antibacterial attacks. And today, one of the most widely used application of nanotech would be electronics. So every computing device you hold in your hand that's post 2010, it is in the realm of nanotech because it's defined as a field of technology which has dimensions lesser than 100 nanometers. One of its dimension is less than 100 nanometers. So, those are two of the main applications that are present out there. And but what's also happening in the laboratories around is to actually bring in another new dimension into how we create products with nanotechnology, as in manipulating the atoms the way we want them rather than looking for atoms and atomic structures that are present that we're referring to as nanotech now. So it's about trying to build things one atom at a time in a configuration that's useful for us.
Most metals we encounter every day may seem smooth and homogeneous, but under a microscope or at mesoscale, you might find grain structures, voids, impurities, and several other features. Uh, and many such features often reduce the strength of a crystalline solid, which is unfortunate because the theoretical strength is several orders higher. Uh, but with nanotechnology and material science in general, it is possible to engineer materials whose properties are comparable to their theoretical limits. And the fact that we can do this by influencing structures at very small scales fascinates me. How did you encounter this field of nanotechnology and material science, and what aspect of it fascinates you?
So carbon nanotubes have been a fascination for me since childhood. So it's mostly been a pursuit of trying to create a world where every one of us can live in space, can go out of the planet, go to other planets, go to other star systems, and live there just like we do now, where we travel to other countries. And we started working backwards from this vision like, okay, how do we create this world? How do we make everything happen? And the first issue, as we came down to the most basic element of it, was that we did not have materials that are strong enough and that are compatible enough for this reality. So we set about trying to find this material, like what is a configuration of atoms that will let humans live and thrive in space. And this particular configuration of atoms exists with carbon due to its high versatility, and it's also its ability to form the strongest bond that we know of in nature. So the structure that could be created from carbon atoms that can have the maximum possible strength is a carbon nanotube. So these are carbon atoms attached with very strong bonds in a tubular structure. They have strengths of up to 70 gigapascals, almost 10 times of carbon fibers. And so to make this, we have to make tubes whose dimensions are just about 6 atoms in diameter, 6 hydrogen atoms in diameter. So this is something that caught my interest. Like, okay, how do we assemble atoms to create such a small tube to get the high strength, which in turn would lead to creation of all this future that I've envisioned since a long time.
Like you said, the diameter of a nanotube, carbon nanotube, is several atoms, and it's around 1 nanometer average. Uh, to put this in perspective, a drinking straw has to be scaled down by 10 million times to resemble a carbon nanotube. Uh, can you tell? Can you talk about how you were introduced to the HIPCO process, which for the listeners is one way to grow a single-walled carbon nanotube?
Yes, HIPCO is one of the methods for making nanotubes, and it was invented by my co-founder, Dr. Kelly Bradley, while doing his PhD under the Nobel laureate, Dr. Richard Smalley. So the nanotubes can be made in different methods, but the challenge was how do you produce nanotubes of a very similar diameter? The allowable errors were within 1 to 2 atoms. And how do you produce something like that? What kind of a machine is required to build it and stuff? I'd been studying nanotubes and been reading about them for a very long time. And then I did a master's in nanotech, specializing in carbon nanotubes, and studied all the different methods of making nanotubes. And there was only one method that could make nanotubes that were repeatable and that could also be done continuously, and this was HIPCO. And HIPCO involves disproportionation of carbon monoxide using iron catalyst particles and then letting them grow into longer strands and then collecting those tubes and repeating the process again and again. So this was the reason, like that I preferred HIPCO, that okay, we need to have a continuous process if you have to make lots of nanotubes, and this continuous process and the progress in that uh, led to this area. And with HIPCO, the advantage is that it's scalable, it's highly repeatable, and it also produces extremely small diameter nanotubes, which have the highest tensile strengths.
Uh, in some of the papers that you've co-authored, you talk about how bringing down the cost and improving the quality of carbon nanotubes were the biggest challenges. Can you talk about these challenges and how NoPo has overcome them?
Yeah, so nanotubes, yes, they have always had two challenges. One is how do you produce the material repeatedly and have a high consistency? And the next thing is, of course, the cost, because cost ultimately is going to decide how many applications are feasible and which applications are feasible. So what we have done at NoPo is to try to figure out what's the best avenue to meet the balance of the highest possible quality, because that's essential for creating any cutting edge application, which makes use of the special properties of the nanotubes. And so we took an approach that's pretty unique in the industry. We took an approach that's derived from the semiconductor industry, wherein silicon wafers have a fixed size. They cannot be scaled beyond a particular size due to limitations of the crystal structure. And hence, people build multiple machines that can process silicon wafers in parallel. So that way, you can produce more devices. That's how you can get a million iPhones on launch day, simply because you have so many machines producing them instead of just one machine trying to churn out the crystals parallel, one at a time, which is what conventional manufacturing does. So we've taken a similar approach. And one of Nopo's biggest assets is our technology to produce nanotubes in reactors that are much cheaper than any time before, while processing them under similar extreme conditions. So this is what gives us an advantage in producing a consistent material and be able to lower costs as we scale operations. So currently, our focus has been on applications which require small amounts of the nanotubes, which still makes a huge difference for the customer.
Can you talk about how the structures of carbon nanotubes are photographed? Because to me, this seems to be the most difficult part, that is validating and qualifying single walled carbon nanotubes.
Yes, so there are a couple of different methods of testing for the quality of nanotubes. So one of them is actually using a Raman spectrometer, in which we apply a laser beam and then we excite the molecular bonds of the nanotubes, and that gives a signal that we then read. It's like you're vibrating the crystals, the molecular bonds, and those vibrations produce light, which is in turn detected, and that gives us a signal about the kind of bonds present and if it's carbon in which form and stuff. Similarly, and besides that, another test is actually to view the nanotubes directly to get a positive confirmation. This is done using an electron microscope, like a transmission electron microscope, so through which we can send the sample, or through which we send an electron beam to the sample and then image it. And this gives us the sizes and dimensions. So using some of these instruments called HRTEMs, we can actually see individual nanotubes. And sometimes people have even been able to photograph the structure with the electron orbital bonds and stuff being visible by like longer duration images and stuff. So these actually give a direct viewing and give a direct capability to see what's being produced.
And do you, how often does this process happen? If you're qualifying a large number of carbon nanotubes, is every batch is every batch photographed and qualified?
Yes, we do. So we like to ensure that what we have produced is the right nanotube. So we actually test every single sample, and we do multiple tests on every sample to make sure that we have gotten the right material. That's something we take very seriously. So oftentimes it's like you only need people only carry out a few tests once in a while, but for us it's like a part of life. Like every run, we make sure it's quantified completely. Only then we move to the next one.
It's my understanding that the growth of single-walled carbon nanotube is terminated when an ion cluster or ion clusters, uh, which are a result of catalytic reaction, are covered with amorphous carbon, and also at high temperatures when these ion clusters evaporate. I'm curious to know if and how this length of single wall carbon nanotubes could be increased, and if it is possible to grow uh, to lengths in centimeters or even meters, or is there a theoretical limit?
So it is possible to keep growing the nanotubes. There is absolutely no limit for that. It's all about producing the feed gas, maintaining the conditions, and you can continue growing it. So there's one collaborator in Swansea who has worked on creating chopped nanotubes. So what they do is they have a process of growing nanotubes from seeds, as in they take an existing nanotube, chop it up into smaller pieces, and then grow longer tubes, all of the exact same size from this original piece, something like a lizard regrowing its tail and stuff. And so that way, people have grown extremely similar nanotubes to very long lengths. There have been researchers in China who have grown nanotubes to a couple of meters that have also been showcased, and these processes do exist. And yeah, so there are ways to overcome the limitations, and it's all about maintaining the right conditions for the growth to happen throughout.
Yes, I asked this because with composites and carbon fiber, it's often advantageous to have continuous lengths of the reinforcement material. So it's nice that it is possible to grow in such large lengths.
Yeah. So yeah, that exists. Like so, there are different ways of utilizing the composites. Yeah, this is one method. Traditional conventional composites is all about having a continuous growing length. Yep, that is feasible.
In the paper on space solar power that you co-authored, a solar cell based on carbon nanotube is presented. which has several benefits that include cost and weight reduction over traditional cells. Uh, can you talk about how the electronics, hardware, and indirectly consumer products can leverage carbon nanotube?
Yeah. So on the solar cell front, so the nanotubes are still they still need a lot of development for them to be able to applicable to be even utilized the way it was proposed to. Because today, whatever technology exists for using nanotubes in solar cells, the efficiencies are very small. They're currently only at 10 power minus 6, but they're growing really, really fast. They're growing exponentially when compared to any other existing solar cell technology, and they have a room of growth unto up to about 80% efficiency, so they would overtake existing technologies and grow beyond them with their rapid iteration. So it should be like, so the last time I checked, like the 10 power minus 6 had achieved 10 power minus 4 within just 2 years, so almost 100x improvement within that time frame. So this is almost a doubling in capabilities every month. And at these velocities, we should see more capabilities from the solar cells. But at NoPo, what we are working on that we have made a huge amount of progress on is water filtration using the carbon nanotubes, wherein we let water flow through each tube. And this is known as a transport phenomena that's unique to the kind of nanotubes that we make. Like, as in, it's a diameter dependent phenomena that's only seen on small diameter nanotubes, wherein the nanotubes seem to be water conductors that do not block the water, they just let it flow much faster. So we are trying to leverage this property of nanotubes to create a new class of membranes for desalination, RO systems, and also for clean water from our houses. Like, as in the waste that we throw out, what if we could purify a lot of it and let out the purified water into our lakes and bodies instead of polluting them with all the sewage lines like is being done today? So these are some areas for which there's no other alternate technology, or the alternates are extremely expensive. And the nanotubes could potentially be the solution that makes the sustainable life feasible. And there are quite a few more areas. There are some where we have worked on sensors that can detect body movements. And there are also applications in pharma wherein cancers can be cured by using carbon nanotubes and IR beams. So this way, there are a wide array of applications.
A bit of a tangent, but I've read that carbon nanotubes have been found in ancient structures in Syria and in pottery at ancient sites in Tamil Nadu as well, and the latter dating back to around 600 BCE. Does history and ancient technology fascinate you? And do you think we should try and rediscover some ancient technology?
So, if you were to dig a couple of meters into the soil, you'll find a thin layer of fullerenes and carbon nanotubes that are dated to be 150 million years old. So, the thing is, anything that combusts, anything that has carbon in it, if you burn it, you're going to get carbon nanotubes, you're going to get fullerenes, and you will have a wide variety of forms of carbon. It need not mean that you had like a precise manufacturing. The carbon that you see on the ground is a geological evidence for a mass extinction event that happened back then. So if you have a forest fire, if you look at the carbon that's produced in the forest fire and you do the same kind of processing described in those papers, you will find carbon nanotubes inside it. You will find fullerenes inside it because they're always present in quantities of about 0.1 weight%. Even your candle suit has carbon nanotubes. Kajal has carbon nanotubes. So it's just present in everything, but not in a form that's actually helpful or usable. You get something called, you get mostly the larger diameter tubes, and you get a huge mixture of different diameters and different sizes. And so it doesn't really lead you to make products, nor does it assert that it was done with active intelligence to create it. So I would say that the conclusions that they were created with knowledge is probably gathering more attention than really being the reality of how it was or what it was created. It just is like like saying that modern science and technology don't matter. But yeah, so I'm skeptical of those results. But yeah, it is true that the nanotubes exist. There is absolutely no doubt about it. They do not exist because somebody knew that they have to be there.
Yeah, I think I also agree in a way. Probably ancient uh, craftsmen weren't aware of what actually was happening, but yeah, we do see some findings. Uh, Moving to space travel, which to me is mind blowing that it is even possible. You've said in past interviews that the reason for starting NoPo is to build your own space program and to visit Mars. Are you collaborating with any space agencies or startups, or are you secretly working on a launch vehicle?
So yeah, secretly I can't comment on that. But yeah, on the things that are outside, yeah, we are working with a company called Python Space. So they're based in California, and we just did a couple of trials on a liquid fuel engine. So this work is happening. So it's meant to be a smaller vehicle that can get down and also help in interplanetary travel and stuff. So that's going on. And besides that, yeah, so we like to collaborate with any of the startups working on the space sector because we happen to have an advantage that nobody does. We make the strongest, lightest material known to mankind. And that's like the perfect thing for use on spacecraft. And we're making continuous improvements to make such large structural materials available. Right now, it's mostly being utilized as smaller scale sensing elements, but not as structural elements. And hopefully, in the next 2 years, we will be having a product which people can use to build their vehicles and make them extremely light.
So, is there a possibility to incorporate, uh, whether through as an additive or as surface coatings, uh, and for carbon nanotubes to be used structurally?
Yes, it is possible to do that. So it is possible to incorporate them into existing carbon fibers as one way of utilizing them. But the ultimate way of using the nanotubes would be in the form that we refer to within NoPo as a carbon nanotube brick, which is a solid structure of carbon. And this has like interlinks between the carbon atoms and creates an extremely strong, lightweight, solid structure that can impart extreme high strength and while being light and having extremely high modulus. So that's something that we are actively working as an R&D project within Nopo on how do we create these interlinks and create this strong material.
I think light sales would really benefit from such technology. I think one of the fascinating problem that some organizations are solving is to visit the nearby stars. So the future is looking good. Uh, Going back to your paper on space solar power, although the aim was to improve an existing design using carbon nanotube, uh, the paper describes several applications like propulsion, high temperature, and radiation resistance. Uh, do you have a favorite or an interesting space-based application for carbon nanotubes that may even be fiction?
Yes, so there are quite a few applications because as I keep saying, nanotubes are like, so if silicon is to electronics, nanotubes are to space. That's what they are and that's what they can create. So what's interesting is there are a wide array of applications, some of which haven't yet been envisioned. So let's imagine that we are living in space, that we're able to travel anywhere in the solar system. One of the biggest limitations is actually going to be the availability of fuel. Like, how do you produce the fuel and oxidizer in space to run with the existing chemical rockets, and how do we go far from that? So unless we have nuclear rockets and or someone develops any kind of these quantum drives and stuff which can use vacuum, we still need to depend on fuel. And one way of envisioning fuel is actually as water. And then if water could be broken down rapidly into hydrogen oxygen, that could lead to much better fuel sources because it's more water is more stable, won't uh, leak off. unless there are openings, and hydrogen oxygen could be produced and utilized. So nanotubes have a possibility of being utilized in such a system wherein they could be used to break down water rapidly by providing a surface that has enough potential to break it down. So this could be an interesting application that could enable like these depots to work that have large surface areas to break down water continuously into hydrogen oxygen, fuel up the vehicle. Like say you call up and say, okay, 2 days I'm going to be there and I need this much of fuel, and your orbital depot converts its water into enough fuel and oxidizer and keeps it ready for you to refuel and flow. And there's no other way to create such things. So this is feasible because of the semiconducting nature of some of the nanotubes, which creates a perfect band gap to break down water.
A bit naive, but I see many parallels to the combustion process in rocket engines when reading about the HIPCO process, like high pressure and temperature, rapid heating, hardware like nozzles, preheaters, and plumbing in general. I have two questions on this. At NoPo, does it feel like you're building a rocket engine? And can rocket engines be repurposed as a carbon nanotube synthesis reactors?
So, so any carbon source can be used to produce carbon materials, nanotubes, and stuff. Now, one interesting thing is, yes, you are right. They have to operate in similar conditions. A rocket engine is generally designed to operate for about 300 to 400 seconds. That's about the peak that you can get out of a chemical propulsion. And after that, it's like you don't really care about it because most rockets today are expendable, few are reusable, and they also undergo maintenance. So the thing is that your burn time every time you have to operate it is only this much, 300 to 400 seconds. While with the HIPCO reactor, we wanted to run for at least several weeks at a stretch. So the system should be capable of withstanding these extreme conditions, operate under similar pressures and temperatures, but still run for a really long time. So this is what makes them far more complicated than a rocket engine to be able to control this processing for a very long time. So that's the challenge that exists with them.
Elon Musk, another visionary and inventor like you, is working on the Starship at SpaceX, which is without a doubt the most ambitious spacecraft in development. If you could redesign the Starship or modify it using carbon nanotubes, what would you do?
Yep. So I wouldn't redesign it. I would just build my own, and that would use the carbon nanotubes as its structural materials. It would not be a two-stage vehicle. It would be a single-stage vehicle, directly being able to get to orbit because it's much lighter and much stronger. And so that could be a great advantage for us, and could actually, and that I think is what's required for space to be accessible to everyone. Think of a luxury spaceship that's taking up its crew, go up there, hang around in space for a few days, and then just come back down to Earth whenever it wants to. That's the vision I see, and that's feasible only if you have a single stage vehicle. And whatever materials we have today, they're not the best for creating such a vehicle.
Yeah, I think single stage to orbit has been the fascination for many since a long time, and I think uh, carbon nanotubes could potentially achieve that. So it's really interesting. Uh, I've heard this before, and I said I wouldn't repeat a question, but can you talk us through the process while deciding NoPo, which beautifully stands for not possible as the name for your company?
Yeah. So it was, so nanotubes were something that I really wanted, and my co-founder to believe that the world needs nanotubes because they're just such an amazing material that improves our lives drastically. But they're really hard. They're extremely difficult to make, and we are talking of trying to make something with dimensions measured in atoms, and that's an insane challenge. Like, how do you make that? And so when we told people, like, say, we want to make this material that's incredible, it's going to change our lives, it's a huge opportunity, it was a lot of deep skepticism. And people were right in being skeptical because There were prior efforts that were done that led to nothing really materializing. There was a lot of knowledge created, but nothing that could be a product. And this led to a lot of disillusionment for everyone. And so the only response we heard from everyone was that it's not going to happen. That, and especially so in India, and especially in Bangalore, because we in India do not make carbon fibers. Carbon fiber yet. So carbon fibers have been made in our laboratories, no doubt. Our incredible scientists have created them, but they've never been commercialized. And all efforts to commercialize them have hit major roadblocks. And carbon fibers are about 6,000 times smaller than carbon nanotubes. And here we were pitching to make carbon nanotubes, the smallest ones, the strongest ones, and the lightest ones, and the hardest ones here. And so it was like, okay, so if people don't believe us, it's still fine. We believe in ourselves, and so we'll have to do this. And so that's why name the company as NoPo. It's like the victories are always sweet when you like disprove all the naysayers, and it also brings everyone onto your side that okay, now it's feasible, we can do things. And so that was the thinking behind it.
You talked about this earlier, but can you tell us where Nopo stands in today's market, and if it is the go-to for research work and commercial applications?
Yeah. So we're known to produce the world's best carbon nanotubes. So many researchers call our nanotubes as the benchmark nanotubes. And so that's like a huge victory for us that we make the nanotubes that are considered as a standard on the planet. And so this is one segment. When it comes to nanotubes, yes, we understand them, we know them, and we know how to make them. So the next segment is about how do we get it into people's hands? Like how do we make something that people can understand? Like if you just have a tube, then nobody knows what to do with it. So we're now helping customers with by creating products from the nanotubes and inserting them into their product lines and helping them create a lot more value for their customers. So this way, we are able to get nanotubes into more applications. So we work actively with partners, and over the years at NoPo, we built a strong multidisciplinary team. So we're not just pure folks from one field, and everyone knows like multiple fields or has the knowledge to gather up information to be able to be useful in that particular field. So for a specific customer from the pharma industry, they wanted a particular molecule, and we were able to create it within just 2 weeks. So this molecule would, in the normal course of research, they've been working for at least 5 years. So this is a kind of speed that's unheard of. So when I used to approach the scientists at some of our national labs and ask them for help in solving a specific problem, and they'll be like, "Yeah, you know what? You can give us a 6 month project, an 18-month project. Give us a PhD student. We'll figure out a solution for you and stuff." And we always felt, okay, there's no urgency to actually solve this problem because without that, my whole pipeline is held up. And so we thought, okay, it's best to help out anyone who needs help in such kind of technology developments. And so we have the knowledge of creating a technology which is thought to be impossible to create. And so we thought it's best to help out every other industry that has an issue that they want to solve. And so we started an R&D as a service department that helps out other researchers, has the same guidelines that NoPo has about creating technology extremely quickly and working on really hard problems and solving them. So this is what we have as our product lines now. So one is the nanotubes and helping customers create the products from the nanotubes and providing R&D as a service so people can solve their tricky problems and move ahead with satisfying the customers instead of being stuck with these R&D problems.
Uh, would working on producing graphene be a downgrade, or do you see graphene uh, being used in as an alternative, for example?
So they're both different materials. They both have different features. They serve different uses. So they are complementary too. So both nanotubes and graphene will coexist, and both of them will target different segments of the market.
Uh, I have some common question that I ask my guests. So, what are you currently working on, both in your career and in your life?
Okay, so for me, both are the same. And so we are continuing to improve the carbon nanotubes, continuing to improve their quality. And most importantly, now we are focusing our efforts towards the composites on improving strength of other materials using the carbon nanotube. So that's our main goal. And post that, we want to start using the nanotube structures in building even larger structures. So that's what we're working on.
Can you name some books that you value?
Yeah, so the most recent one that I like is called The Effective Executive by Peter Drucker. I thought it was a really good book that talks about how to manage things. So besides that, one favorite book is called As the Future Catches You. So this is about how technology is changing and how knowledge economies are going to disrupt the world we live in. And there are quite a few more books, but they're all like subject, like they're just related to specializations. And yeah, so and if somebody wants to reach out about them, I'll be happy to suggest.
Uh, and what about values in life? What are some values that you think are important?
It's important to be truthful, to be able to say things as they are, irrespective, even if they are hard truths. So that's one thing that's most important. And yeah, so if that's there, then everything else will be there because that builds trust. And once you build trust, you get people to work with you and believe in whatever it is that you're creating.
Finally, where can people find out more about you and how can they connect to you?
Sure. So the easiest is on the website. They can reach out to nopo.in and they can find out a lot of information about the company because we believe in sharing knowledge as much as possible. And yeah, that's probably the best avenue and contact forms there. So I'll have access to some of the contacts. And yeah, and when somebody reaches out, that's how we can get in touch.
Gadhadar, your work and passion inspires me, and I'm very fortunate to have had this opportunity to speak with you, and also for responding to some of my curiosities. So, thank you so much for taking time to speak with me.
Sure. Thank you.